The final module that we're going to work on before we start our final project is Module 9, Threaded Fasteners. In this module, we're going to look at how to draw bolts and screws, tapped holes or holes with threads in them, and then threaded assemblies. So there's a little bit of background that we need to discuss first, or we need to look at. All of this that I'm going to talk to you today about is covered in Chapter 10. It is going to be very helpful to reference Chapter 10, to have it open while you're doing your quiz. There's a quiz in this part of the module, and when you're doing the assignments, okay, the drawing assignments. So before we get started with this, let me just give you a little bit of a preview. So I will be going through this presentation, and then and it's a short presentation, only 11 slides. Like I said, it references the Chapter 10 in your textbook, so please refer to that for any further questions that you have or any more details that you need. And then later on, I'll be doing 3 videos. There's 3 drawings that are required in this assignment. There is a inch fastener assembly, a metric fastener assembly, and a fastener drawing. So those 3 drawings, I'll be doing 3 separate videos for those. Okay, so let's get started with the presentation. So this is Chapter 10 in your textbook. So one of the first things that we have to figure out when we start to draw threaded fasteners or any type of threads in a drawing is how are we going to represent the threads on the drawing. Okay, we don't just draw the threads in their actual appearance or the way that they actually look in real life, because that can be very complicated. We have options to simplify the threads and how they look in our drawing. Okay, so there's actually 3 different ways that we can draw threads. Okay, there's the simplified form, the schematic form, and the detailed form. As you can tell, the detailed form is the most closely related to the actual threads on an object, the actual threads that you can touch. For this reason, we rarely see detailed threads drawn on a engineering drawing because it's very difficult to draw, and some of the dimensions even for getting some of these details are hard to come by. So the detailed form is not very common at all, okay? The other 2 forms, the simplified and the schematic form, you'll see them much more often. The schematic form is the middle one over here, and you can see this kind of looks like threads, right? We have a root line and we have a crest line here, and they alternate, so we can kind of see that. But for this reason also, and you have to think on a drawing, on an engineering drawing, a lot of times there's going to be a lot of detail in that drawing, okay? So to add this level of detail for threads, oftentimes unnecessarily, will detract from the overall appearance of the drawing. And it can be actually a bit challenging to draw sometimes, especially in assembly. So for those reasons, schematic and detailed are not typically found in a drawing. The simplified form is the most common way to represent threads in an engineering drawing. Okay, the simplified form is going to have an appearance like this. This is, of course, an external thread, right? Not a hole, but an external thread. We have hidden lines here that represent what would be the minor diameter across here, and the major diameter is represented with the visible line. The thread length is from this line to the end of the fastener, and then we also have a chamfer on the end of the fastener. Okay. So we're going to go through all the details with how to draw the simplified form, and that's what you're going to be using on, or that's what you're going to be drawing on your 3 drawing assignments. Okay, so when we go to drawing the threads in a hole, a tapped hole or a blind hole, whatever it is, the threads are going to show up like this on the drawing. Okay, so the top is the simplified form, and the bottom one is the schematic form. I left off the detailed form because it's just rarely ever drawn, and you can actually see examples in your book, but we're just going to focus on the simplified and the schematic. So let me just explain what you're seeing here first of all, because I think a lot of people get confused. So they're trying to show you different views and how the threads are shown. So if we look at the simplified format, this is the top view of the thread, okay? So the outer diameter here, the hidden circle, represents the major diameter. And this is going to be important. We'll talk about this later, but this is one of the key dimensions that you're given when you're trying to draw threads, is the major diameter, and that represents the hidden circle. All right, the inner circle here, the visible solid circle, is represented typically with just a standard offset, like a 0.06, 0.09, 2 millimeters, whatever it is. I will show you a table where you can get those values, okay? So now this is the top view. When we get to the side view, what they're showing you here, this is actually 4 different side views, because, you know, this is what the side view of this hole looks like in a hidden representation. Notice the double pair of hidden lines, right, corresponding to these lines coming across here. And this is what the section view of the threads look like. All right. So again, we have the hidden lines on the outside of the visible lines. The hidden line represents the major diameter across here. All right. And then these last two here are what happens if we have what's called a blind hole. Now, a blind hole is the term for a hole that doesn't go all the way through the object. So it stops at some point, and you can see that stops here. So this is a hidden representation of a blind hole, and this is a section view of a blind hole. The other thing I'll note here is that the section lines on the section view goes through the hidden lines. All right, that's going to be important because you're going to be drawing this type of representation. All right, the bottom is the schematic form. All right, and you can see that we're replacing the in the section view only, we replace the hidden lines with the crest and root lines here. Same thing over here. Notice that the hidden view is identical. Hidden view is identical. Okay? All right, so we'll revisit that. Of course, that's how we're going to be doing our drawing, so we'll return to this. The other factor that we have to consider is how do we actually dimension, or how do we apply a dimension notation to the threads, okay? And there's 2 formats for that. There is an inch notation and a metric notation. So for an inch notation, you're going to need to know these 6 factors here. The major diameter, the number of threads per inch, the thread form, thread series, class of fit, and thread length or depth. Okay. Now, the good news is all of these are given, or you can find them in tables. All right. So how do you represent all this on a drawing to dimension a hole, a threaded hole, a tapped hole? Well, like this. Okay. So we're going to use a leader. We're going to point to it, and then we're going to give first the major diameter, then a dash, and then the number of threads per inch, the thread form, in this case Unified National, UN for Unified National. C is the course series, the thread series, and then dash 2B, where 2 represents the class of fit, and B is internal or external thread, right? B stands for an internal thread, that is a threaded hole. A, if you look down here, represents an external thread, or a screw or bolt or fastener of some type. All right, and then optionally, if it's a left-hand thread, then you put LH on the end, but typically it's not a left-hand thread. Okay, so this would read 0.25-28 UNF-2A, right? For a quarter inch major diameter, 28 threads per inch, Unified National thread form, fine for the thread series, so it's a fine thread. 2 for the class of fit, so it's a medium fit. And then A for an external thread, which means it's a fastener. Okay? Now, for a metric thread, it's a little bit simpler, right? So we only need to include these 4 items on the thread note: the major diameter, the pitch, the thread form, and the thread length or depth. Okay, so here in this example, M10 by 1.5-6H LH means a metric thread form, M for metric thread. 10 is the major diameter, so 10 millimeters across the hidden circle. By 1.5 is the pitch, so what that means is that's 1.5 millimeters between, that means 1.5 threads per millimeter, okay? 1.5 threads per millimeter, or 3 threads every 2 millimeters. 6H is the tolerance grade, all right? And we actually are going to omit that. We're not going to use any tolerances for our threads. We'll cover that in a later class. So if you're taking the detailing class, that's where we cover the thread tolerances. Okay? So, looking more at the drawing, how do we draw threads in an assembly? Well, here I have 2 examples. This is a simplified bolt that's assembling two features with clearance holes, right? So we have a hole here in this top feature and a hole here in the bottom plate. This is going through a clearance hole, and we have a nut on the end of that that's holding these together. In this example over here, we have a clearance hole in the top plate, but in the bottom plate we have a blind tapped hole. All right, and you can see that we have the thread continuing down to here in the hole, and then the hole, the drilled hole, actually extends further past that. Again, we're not going to get into too much detail on how to dimension the blind tapped hole. That's covered in a later class. Okay, we'll use some rules of thumb for that. So the types of holes, I've already talked a little bit about this, but just to give you the definition, a blind hole is a hole doesn't go through the feature, right? It's going to have a clearance hole on the top plate, but the fastener is going to thread into the hole. So a blind hole is a hole that doesn't go through an object. A blind tapped hole would be a blind hole that is tapped, that has threads cut in it. A tapped hole is just a threaded hole, and a through hole is a hole that goes through the feature. Okay? So when you're drawing, now here's some guidelines for how to draw a hole. Obviously this is in section view. This is the hidden view of this. This is just the hole caused by the drill bit. So this is what we would call a blind hole. And then when we tap it, as in we cut the threads into the hole, we don't typically cut the threads all the way to the bottom of the hole, right? So in this case, you can see the threads stop right there, right? And I can see the thread represented by the hidden line here. So this is a simplified format. Now, in some cases, you do use what's called a bottoming tap, and that's a tap that's designed to go all the way to the bottom of the hole. But we're not going to draw those, so you don't have to worry about that. All right. So here's some dimensions on how to draw bolts and screws. This is kind of complicated, so I'm going to show you a more simplified representation of this. But this is, I like this drawing because it puts everything right in front of you. In this one drawing, you can see all the dimensions for how to draw a bolt or a cap screw with a nut. All right, so if you need a drawing to go to for all the dimensions, this is the slide to give you that. Cap screws, of course, they're typically smaller than a bolt, and as the definition says, a cap screw is a threaded fastener that joins 2 or more parts by passing through a clearance hole in one part and screwing into a tapped hole in the other, right? So the bottom part here, this plate, has a blind tapped hole, right? You can see that here. This top plate has a clearance hole in it, all right? And so this is what a cap screw is. And again, these are all the dimensions that you need for drawing a hex head cap screw, flat head cap screw, round head cap screw. You can see what that looks like. Philister head, and a hex socket cap screw. Machine screws are very similar to cap screws, except that machine screws typically have fine threads. Okay, so the thread count is higher on these. Mostly they're also available in smaller sizes. All right, so here we have a round head machine screw, flat head machine screw, oval head, and Philister head. I would note on this, one of the differentiators between a cap screw and a machine screw is that machine screws do not have a chamfer on the end of the thread. So if you see, this is the fastener here. Notice that the end of the fastener is square on all of these. The end of the fastener right there is square. Now, if we look at the cap screw, notice here the end of the fastener has a chamfer on it. Okay, so that's one difference. I'm not even going to say big difference, but difference in drawing a machine screw versus a cap screw. And my friends, that is the end of the presentation for this. Okay, now I will be referring to this presentation when I'm doing the drawings. I'm also going to be referring to the CAD standard, so you'll need that with you, and also tables in the back of the book. So you will need your book on this assignment, Module 9. You will need your book. You're going to be referencing some tables in the back, and there's a lot of good information in the chapter. Again, this is Chapter 10, Threaded Fasteners. All right, so that concludes the presentation. I'll see you in the drawing videos next.